Hi, my name is Angel Walker and I'm the coordinator of this project too.
Hi, my name is Viet Nguyen.
And my name is Jamil Bakhtyar, and our group name is CSC Programmers 3210.
Our main task for this project too was to familiarize ourselves with parallel programming as well as continue to work with ARM assembly programming as well as the GNU debugger in order to verify our results throughout our programming. Inside of the ARM assembly programming, we are able to debug our program by adding a G flag while assembling and linking the executable file and running the GNU GDB debugger. Adding to what we previously learned in our last project, we learned to step over command in order to move to the next instruction. Also using the info registers command in GDB, we were able to analyze the values stored in the register, which shown here is our arithmetic 2 program. Lastly, we looked at 3 hexadecimal values starting at the location of our breakpoint using its memory address shown below.
So 2 key things we learned from this project is ARM assembly programming and parallel programming. For the ARM assembly part, using our second S program as a reference, we wrote a program that calculates val 2 plus 9 plus val 3 minus val 1 and put it into a register. So valve 1 is 11, valve 2 is 11, and valve 3 is 16. The final value should be 30 in our register. So to check the value, after assembling, linking, and running the program, we launched the GNU debugger and verify our result. As you can see in the picture, at R1 in the info, it say that the value is 30, which is correct.
Alright guys, as Viet just talked to you guys about ARM assembly programming, I will let you guys know a little bit about parallel programming basics. We started off by creating a file named spmd2.c, and we basically got all the contents for this file under the parallel programming task. And once we had all the information inside this file and we ran it and executed it, we got outputs that had repeats essentially. So you would see hello from thread 2 of 4, hello from thread 2 of 4, hello from thread 3 of 4, hello from thread 1 of 4. As you noticed, thread 2 of 4 did repeat twice, and this was because some of the cores share one bank memory, and ultimately we fixed the code by going back into the file and we commented out line 5 by using forward slashes, and then we went over to line 12 and 13 and we added int to the front of those lines, and that ultimately got rid of our repeats.
Throughout this project, we learned a lot about things that could be put towards our further assignments in class. We definitely will need to know parallel programming when it comes to doing further projects, as well as working with the Raspberry Pi, ARM assembly programming, as well as the GNU debugger. We will need to use this debugger in order to understand how our programs are verified and how the results are turned out.
In addition to that, we can use parallel programming and ARM assembly programming for future classes, because once you learn a language, your mind adapts to learning in different ways. Your thought process changes a little bit, and basically we can move forward. When we're learning another language, we can take these concepts that we've learned and the thought process that we experienced and the hardship that we experienced, we can take all those and basically apply it to the new language.
So for future jobs, since we have acquired some experience with the concept of parallel programming, so we are better prepared for jobs that involved database server and big data.
The most challenging thing that we encountered throughout this project too, I would say, is dealing with everyone's schedule, testing throughout these past 2 weeks, and just being able to be on one accord with how we will meet, what time we will meet, and where. Though, when it comes to the best challenge, once we finally got together and had the time to get started on our project and be able to work as one on our tasks, we were able to work very diligently and be able to get everything done in a timely manner.
Now, one of the worst experiences we've had so far with the Raspberry Pi, the first time around on the previous project, we didn't have much of an issue because the monitor that we used in the library had an HDMI cord. Now, we didn't realize that all monitors in the library do not have HDMI cords. So we actually set up a few library rooms and we tried to set up the monitors in there. Those didn't work, so we had to go out to a computer where all three of us were sitting and literally took the computer apart just to use the monitor. But once we had it set up and going, like Angel was saying, we knocked it out of the park.
Thank you for watching. Stay tuned for our next project.
Yeah.